Hello guys, InspiredDoc here. Today we're gonna talk about homeostasis. What is homeostasis? In our body, there are many reactions taking place constantly. Why these reactions are occurring? It is so because the different parameters of our body like temperature, pressure are always changing. To keep that in constant, we need to do some reactions. Need to do reactions is not that we have to do the reactions, the body does the reaction by its own. Now what would happen if these reactions are stopped? What would happen if these changes in parameters are not corrected? Yes, that would lead to diseases. So we need to know this mechanism, why we try to keep homeostasis and how is it kept. Why? I already told. It's because we need to protect our body from getting infected or getting ourselves sick. Now how this homeostasis is maintained in our body? It is done by different mechanisms. What are those mechanisms? The positive feedback mechanism and the negative feedback mechanism. Now, each mechanism has its own subunits. What are those subunits? Number 1, stimulus. Number 2, receptor. And number 3, effector. Now, let's take these mechanisms one by one. Positive feedback mechanism. In positive feedback mechanism, the stimulus is in one direction. Now, the response which is produced in our body is also in the same direction. Let's take an example. Now, we think about blood clotting. If there is a cut in our body, কোথাও আমাদের বডিতে যদি ছড়ে যায় বা কেটে যায়, blood বেরোতে থাকে. Now, our body can't tolerate the loss of blood from our body. So it tries to stop it by clotting that area. Clotting কিভাবে হয়? By a series of reactions. Now with each reaction there is an increase in number of reactions at each step. That's why we don't tell that this is a simple chain of reactions, but rather this is a cascade of reactions. Why we are saying cascade? Because cascade means amplification. Increase in the amount of reaction at each step. As for example, if the first step is occurring once, then in this next step the same step would be occurring 4 times or 5 times. Why is this done? So that the end product which the body is trying to produce would be in large amounts in a small period of time, hence preventing the loss of blood as soon as possible. We can also take other examples like LH surge. The LH surge, which takes place on the 14th day, usually occurs due to the continuous stimulus of estrogen and FSH during the follicular period. After this follicular phase is at its end, the estrogen level and the FSH level increases so much that there is a positive stimulus which results in more release of LH. This leads to LH surge, and this LH level reaches the LH peak where ovulation occurs. We can take other examples like action potential. In action potential, whenever there is a stimulus at one point, there is depolarization of the nerves in that region. If there is depolarization, there is sodium ion influx, which actually stimulates more sodium ion influx and results in the transfer or the transmission of the nerve. We can take other examples like hypovolemic shock. Okay, so let's talk about the negative feedback mechanism. In negative feedback mechanism, the stimulus is in one direction, but the response would be in the opposite direction. To counteract the change a parameter in the body. Let's take some examples. Just like the regulation of blood pressure in our body, the regulation of blood glucose in our body, these are all examples of negative feedback. In our body, suppose there is increase in blood pressure. So the stimulus here is the increase in blood pressure. The receptor is the barometer, and the effector is our brain, more particularly the medulla oblongata, which tries to give a response so that the blood pressure in our body decreases and brought back to normal. This is negative feedback. Same goes for blood glucose. There is increase in blood glucose in our body. So in response to that, there is release of insulin, and boom, there is decrease in blood glucose. So these are the mechanisms by which we can maintain homeostasis or constancy. Now there is one more mechanism which many of us don't know. It is the feed-forward mechanism. What is feed-forward mechanism? Now, in the previous two mechanisms, we were talking about feedback control, feedback mechanism. We get a feedback from the body, but here it is feed forward. That means the body doesn't get any stimulus. There is no stimulus. Rather, the body anticipates that there is gonna be a change in the body parameters, and the body tries to counteract that change in parameter. That's why this mechanism is known as anticipatory mechanism. So let's make this feed forward mechanism a little bit easier with few relevant examples. Suppose we think about doing some exercise. What happens in our body? There is a slight increase in heart rate and respiratory rate. Why? Because whenever we do exercise, there is lack of oxygen for the tissues inside our body. To compensate that loss of oxygen, the body starts to increase the heart rate or the respiratory rate as soon as we think about doing exercise. Okay, let's make this mechanism a little bit more easier. Whenever we feel cold, তখন আমরা কি করি? আমরা কাঁপতে শুরু করি, shivering, right? Now for this we need to know some terms. The temperature which is present on our skin, this temperature is the body shell temperature. Shell means outer covering. The skin is our outer covering, right? So this is the body shell temperature. And the temperature of the organs present in our body, this is the body core temperature, because the organs, the inside of our body forms the core of our body, right? So the core body temperature. Now wherever there is cold outside, what happens? The skin temperature or the body shell temperature lowers. This leads to lowering of the core temperature as well. Now this cannot be done. This is not allowed. This is not good for our body. So our body anticipates this lowering of temperature, so it starts shivering. This is how homeostasis is maintained by these three mechanisms: the positive feedback mechanism, the negative feedback mechanism, and the feed forward mechanism.